So if you've ever built a PC, or even just upgraded one, you've definitely hit this wall. Do you shell out the extra cash for one of those super fast NVMe SSDs, or is a good old SATA drive really all you need? I mean, the numbers on the box are just astronomical, but what you get in the real world, well, that's a whole other story. Let's get into it.
All right, here's the game plan. First, we'll look at the incredible speeds that NVMe drives promise. Then, we'll hit a major reality check from some real-world tests. After that, we're going to uncover the secret behind why the numbers don't always match up, figure out who really needs this kind of speed today, and then we'll look at the future and the one piece of tech that's about to change everything.
Okay, let's start with the promise. The marketing for this new generation of storage really boils down to just one thing: absolutely mind-bending speed.
And this right here is the magic wand that makes it happen. NVMe, that's Non-Volatile Memory Express. It was built from the ground up to use that super-fast PCIe bus right on your motherboard, basically leaving the old SATA connection in the dust. This is the top of the mountain for consumer storage right now.
Now, just take a second and look at this number: 14,900 megabytes per second. To put that in perspective, a really good SATA SSD tops out around 550. This is more than 25 times faster. The promise here is just staggering.
And it's not just theory. In benchmarks designed specifically for gaming storage, the difference is huge. You can see here in the 3D Mark test, the Gen 5 drive just demolishes its Gen 4 predecessor, scoring almost double. So, on paper, the advantage is massive. It's undeniable.
So, with numbers like that, you'd think your gaming experience would be completely transformed, right? Loading screens would just vanish. Well, this is where our story takes a very, very sharp turn. This is the million-dollar question, isn't it? If the benchmark scores are nearly double, our games should be loading in half the time. That's how it works, right?
Well, check this out. A Reddit user named Dracoon did this simple thing. They got out a stopwatch, they tested loading times in a game on the exact same computer, only swapping out the drive between tests. And the results are, they're basically identical. We are talking about fractions of a second separating a drive that is theoretically 20 times faster. This isn't just a gap between hype and reality, it's a chasm.
And here's their conclusion, straight up. For a single-player game, the extra cost for NVMe just didn't seem to be worth it. So what on earth is going on here?
Okay, to figure this puzzle out, we have to understand a crucial concept. Not all speed is the same kind of speed. The whole secret is buried in the difference between two types of data access.
So, here's the deal. That massive 14,900 megabytes per second number, that's what we call sequential speed. It's amazing for reading one giant file from start to finish. Think of streaming a huge 4K movie. But games don't work like that. A game has to load thousands of tiny separate files all at once. Textures, sound clips, character models. That's a random workload, and it is a totally different animal.
And this is the gaming bottleneck. Because games are a random read job, the thing that matters most isn't the top speed or throughput, it's latency. How quickly can the drive find the beginning of each of those thousands of little files? And here's the kicker. When it comes to latency, both SATA and NVMe SSDs are already incredibly fast and, most importantly, very, very similar to each other. That's the real reason the load times are almost identical.
Just so we're all on the same page, let's do a quick definition. First up, SATA. This has been the standard for years. It connects with a cable, and because of that interface, it pretty much maxes out around 600 megabytes per second.
And then you've got NVMe. This is the newer protocol that plugs right into that fast PCIe slot on your motherboard. It was designed from day one to just blow past that old SATA bottleneck and let the drive really open up the throttle.
Okay, so if NVMe isn't a silver bullet for most gaming load times right now, then where does all that incredible sequential speed actually matter? Is it just for bragging rights?
Well, the answer is in tasks that are pretty much the exact opposite of gaming. We're talking about jobs that have to crunch through enormous single files.
This is where an NVMe drive is an absolute monster. If you're a video editor working with massive 8K footage, or an engineer rendering huge 3D models, or even a data scientist training an AI on a gigantic dataset, that sequential speed is a lifesaver. Moving a 100-gigabyte file takes seconds instead of long, painful minutes. For these folks, an NVMe drive isn't a luxury. It's a fundamental tool for getting work done. But, and this is a huge but, the story is far from over for us gamers. There is a new technology that's just starting to hit the scene, and it was built from the ground up to finally let games use all that power we've been talking about.
See, for decades, the way games got their data from storage has been, frankly, really inefficient. The problem wasn't just how fast the drive was, but the ridiculously long and winding road that data had to take just to get to your graphics card. So, traditionally, every little texture and sound file had to go on this epic journey. The SSD sends it to the CPU has to stop what it's doing and decompress it, then it goes to your main system RAM, and only then does it get copied over to your GPU's memory so it can actually be put on screen. Your CPU becomes this massive traffic jam.
But now, we have the new way, Microsoft's Direct Storage API. This completely changes the game. It builds a direct superhighway from your NVMe drive straight to your GPU. Compressed data gets fired right over to the graphics card, which is an absolute beast at decompression, and the CPU bottleneck is just gone.
And this is the critical part. Direct storage is built specifically to take advantage of NVMe drives. It uses their ability to handle thousands of requests at once, something SATA drives just can't do. This new tech makes a fast NVMe drive not just a nice bonus, but an absolutely essential part for the next generation of games.
So, what does this all boil down to? It means that direct storage is the software key that finally unlocks the hardware's true potential. It's the thing that takes that myth of insane game loading speeds from the marketing box and finally makes it a reality for gamers.
And that leaves us with one final and really exciting question. When developers don't have to design games around loading screens anymore, when they can stream these gigantic, beautiful worlds directly from the SSD to the GPU in the blink of an eye, what kind of games are they going to build? The bottleneck is finally breaking, and the future of gaming is about to get a whole lot faster.